This lesson is about normal distribution. So it says many populations have a distribution that can be well described with what is known as the normal distribution or bell curve. This curve shows the percent or proportion of a normally distributed data set that lies certain amounts from the mean. So these are going to be those keywords that you're going to see in every single problem. Every time you see it say that it's normally distributed the data, it's going to follow this, what we call bell curve. And they call it the bell curve because it looks like a bell. So what this means here is all of your data should fall somewhere inside of this bell curve. No matter what data it is that you're looking at, whether it's our test grades from a certain test, your Regents scores, ACT scores, SAT scores, you name it, data should follow this same type of looking bell curve. Along the bottom, these are what we call standard deviations. And a standard deviation, or sigma, we use sigma to represent it. A standard deviation is a measure of how dispersed the data is in relation to the mean, which means how far away are you from the mean? The mean, remember, is the average. So right down the middle of the bell curve, notice it has a 0. That's because this is where you are the mean or the average. Your mean or average should go in the middle. Coming off of that, notice it's kind of like a number line. As we go towards the right, the numbers are all positive. As we go towards the left, the numbers are all negative. So anytime you are to the right, it means that you are above the mean or above the average. Anytime you're to the left of it, it means that you are below the mean or below the average. Now, we really only look at the solid numbers, so the 1, the 2, the 3, the -1, -2, -3. So if I'm at, let's say, the +2, it means that I am what we say 2 standard deviations above the mean. If I was at the -2, then I know that I am 2 standard deviations below the mean. The bigger the standard deviation, the larger your numbers are from each other, the further away they are from each other. The smaller your standard deviation, the closer all your numbers are to each other. So let's say, for example, that on our last test, let's say that the mean was 85 and a standard deviation or what we call sigma, was 5. So that means that if I'm looking at this bell curve, right down the middle would go my mean or my average. Where I had, let's say, the +1, +2, and +3 before, I would have the +1, meaning I am right here, 1 standard deviation above the mean. Right now, I said that 1 standard deviation was worth 5. So if I am 1 standard deviation above the mean, it means I am 5 points above the mean. So 85 plus 5 means that I would have a score of 90 if I was 1 standard deviation above the mean. Meanwhile, on the other side, if I was 1 standard deviation below the mean, it means that I would be 5 points less than the mean, and my score would have been an 80 on the test. Next, if we are, let's say, 2 standard deviations above the mean, I already know 1 standard deviation above, I would have a score of 90. So if I'm 2 standard deviations above, I'll be 5 more points above, which means I'd be at a 95. If I was 3 standard deviations above, I would be 5 more points, which means I would be at a score of 100. I could keep going down the other way. If I was 2 standard deviations below the mean, I would be another 5 below the 80 that we left off at. I would have a score of 75. If I was 3 standard deviations below the mean, I would be another 5 points below. I would be a 70. So notice all of these little percents that we have here everywhere, all these percents. These percents add up to 100. It means that 100% of our data falls inside of this normal curve. So according to these numbers over here, all the scores on the test should fall, according to this data, between a 70 and a 100. So this exercise here says, for a population that is normally distributed, find the percentage of the population that lies within 1 standard deviation of the mean. Okay, so what does that mean here on our normal curve? So let's take a look at the normal curve. Let's erase everything so we can see it. We want to be right now within, so that means inside 1 standard deviation of the mean. So 1 standard deviation of the mean means that I could be 1 above it, or I could be 1 above it. So we could be 1 standard deviation above, or we could be 1 standard deviation below the mean. All I know is I am 1 standard deviation away from the mean. So here's my bar, my line for the negative 1. Here's my bar, my line for the positive 1. And we want to know how many are within the 1, meaning inside of the 1 standard deviation. So we're going to take all the percents that are inside. So we have 15, we have 19.1, another 19.1. Our normal curve is symmetrical. Another 15, and adding up, we get that it's 68.2%. This means that 68.2% of your data that follows a normal distribution, 68.2% of the data, more than half, should be within or inside of 1 standard deviation of the mean. It could be 1 above the mean or it could be 1 below, but as long as you're inside of that range, you should have 68.2% of your data. Now on the next one, it says, what percentage is within 2 standard deviations of the mean? So now I could be 2 below, or I could be 2 above the mean. Again, it says within, so we go to the bars at the -2 and +2, and now we're going to add up all of the percents that are inside of the -2 and +2 range. So adding up all of those percents, you're going to do 4.4 plus 9.2 plus 9.2 plus 15 plus 19.1 plus 19.1 plus 15 plus 9.2 plus 4.4. And we're going to add it all up. Oops. 9.2. And when you add it all up, we get 95.4%. So 95.4% of the data should be within 2 standard deviations of the mean. Next, we're going to add up the 3. So now it says how many are within 3 standard deviations. So now we're going to go to the -3 and the +3, and we're going to add up all the percents that are between them. For this one, when you add up, you should get 99.8%. 99.8%, so almost 100%, pretty much all of your data for the most part, should be within 3 standard deviations of the mean. So if we look back over here, that means that between the 70 and the 100, 99.8%, so almost all of the data, should be within that 3 standard deviations. So this brings us to important. This is what we're going to end up using for the regions. You don't get this big curve with all these percents in it for the regions. So instead, you just have to have it memorized what all of our numbers were. We do round, so at least you don't have to remember all of those little decimals. So for the 1 standard deviation of the mean, up here we got 68.2%. For the regions, if you are within 1 standard deviation of the mean, again, you could be 1 above or 1 below, we round to just 68%. Next, if you are within 2 standard deviations of the mean, and this is the most popular one, the Regents loves this one. If you are within 2 standard deviations of the mean, we round to 95%. And then last, if you are within 3 standard deviations of the mean, this one a little bit weirder when we round. This one rounds to 99.7%. I don't know why they cut off just that little 0.1, but that's the way they do the rounding for the regions. So this is what we call the empirical rule. These are the percents that all of our data falls between. These are the percents that we're going to use for the regions and for all of our questions.